Hey, what's up, guys? This is Chung here. So this time let's take a look at another Codeforces problem. This one, Unmerge. So, so the description of this problem is a little bit long, but to summarize what it's saying is there is like this merge function logic that we can utilize. So this merge is kind of like a merge sortings, and basically, we have like a we have a array here, we have array A, and we have array B here. So we start merging from the first element, and whenever the first one is whoever is smaller, we'll just put that one into the merged array. That's what that's what it's saying here. So if this A1 is smaller than B1, then the merged one will be, so basically we'll pick this A1, okay, and then if the B1 is smaller, we'll pick the B1. So for example, if we have 3 and 1 here, right? And then to merge this one, we have x, 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 right? So here we'll put 1 here. And let's say we have 2 here, and we have 4. So since we have 1 here, and this since the 2 is also smaller than 3, that's why we have a 2 here. And then we have 3 and 4, so on and so forth, until we have consumed all the numbers in this two array, and then we got a merged array, right? And here it says the algorithm has a nice property that if A and B are sorted, the merge A and B will also be sorted. Yeah, that's basically how this merge sorting works. And but now, even though we have this merge logic here, but we don't necessarily have to use it in the sorted array. So basically here we're using it on the unsorted array here. And then you're given like a permutations of n distinct integers from 1 to n. Okay. And then it asks you that given like a permutation of a n, can you verify if that permutation can be obtained by splitting that permutations into two subarrays. If we can, then we return yes. Otherwise, we return no. Right. So that's how this description is saying, and the input is like this. So input, the first one is the single integers, right? It's 1,000 test cases, and then the next one is the single integer of n. So which means that uh, we have two subarrays whose like length is are both n, and then the second line of is the test case. Basically, the permutations, right, from 1 to 2n. And it's guaranteeing that P is a permutation, which means that each element is distinct, right? Okay, and then the then it asks us to check if this one can be obtained by merging two of these subarrays. So for example, right, we have 2, 3, 1, 4, right? And so 2, 3, 1, 4 is true because the 2, 3, 1, 4 can be merged by using 3, 1, 2, 4, because so the merge this, we have 2, and then we have 3 and 1 and 4, right? And second one is 3, 1, 2, 4, which is false because this one cannot be obtained, cannot be get by splitting these four numbers into two subgroups. So same thing for this one, right? So this one can also be merged by using these two sub array here. Yeah, so that's the that's the description. And so how do we solve this problem, right? And let's say let's just use this one as an example. 2, 6. Let me write this down here. So we have 2, 6, 6, 1, 5, 7, 8, 4. Okay. So we have 3, 2, 6, 1, 3, 7, 8, 4. That's the that's input. So to solve this problem, so I think one of the key observation is that the anything anything that is smaller. So from the 3 here, anything that's smaller than 3, for in this case is like what is the 3 2. So this one has to be in the same array. Same thing for this one. Same thing for the 6 1 3, and then 7, and then 8 4. Basically, as long as we haven't seen a number which is greater than the starting point, then the this blocks has to be in the same group. And why is that? I think it's not too hard to prove that, because let's say 3 and 2, they are in two different uh, arrays, right? If that's the case, 2 would have come before 3, because 2 is smaller than 3. Uh, we can get this 3 2 only when these 3 2 are in the same group, which is like 3 2 something. Then we can get 3 and 2. Otherwise, if 2 is here, then we instead of 3 2 we'll have 2 3, right? So that's the same thing for this one, right? Same thing for the 6 1 3 here. So which means 6 1 3 has to belong to the same group, to the same array. And then we have 7, we have 8 and 4, so on and so forth. And once we have that observations, then we can do what? We can just partition. We can just partition this array into several blocks, right? So we have 2 here, we have 3, we have 1, and we have 2. Okay. Then the problem comes down to, with this kind of different length of blocks, can we find a combination that uh, we can get the a length of 4? If we can, then it means that we can find two subarrays that can form this one. Otherwise, it's false. And as long as we can find the like the combination like of blocks that can satisfy this target, it doesn't really matter which blocks we pick, because there could be multiple answers. Why is that? Let's say we have 3 1, because here, as you see, so here we only have one options, which is this 3 2 and 8 4, and then we have a 3 1 6 1 3 and 7. So that's why there's only one combination here. So let's say, for example, here we have 3 2 4 3 1 4 2 6 5, and then 8 7. Now we have 4 blocks whose length are all 2, and the target is also 4. So in this case, we can pick any of those twos to construct a subarray, and the result will be the same. So for example, if we try to use the 3 1 4 2, if we try to use this one as array 1, and then this 2 as array 2, so what do we have? We have 3 1 4 2 6 5 and 8 7, right? So and it works. So same thing for if we try to use this two as a group. So we have 3 1 6 5, and then we have this two, which is 4 2 8 7. So if we try to merge these two arrays here, so what we have? We have 3 1, and then we have 4 2 6 5, and it's 8 7. Same thing, right? So, and why is that? Because the since we have already grouped we have already made sure that all those blocks will belongs to the same group. As long as that holds, that fact holds, every time when we consume the first group, the first blocks, we will somehow consume the second blocks altogether, and then the third one, and then the last one. So that can guarantee us, we will always get the this this merge the merge results. Okay, so once you figure that out, so the rest is what? Basically, now the problem becomes to a 0, 1 knapsack problem. And once we have all this kind of the length of the blocks, all we need to do is we just need to use a DP, right? For 0, 1 knapsack, and to figure out with this kind of candidates, can we use some of those numbers to get a 4? And or whatever target is. If we can, then we output yes, otherwise false. Yeah, so I think that's it, and let's start coding. So to start the codings, let's define the range of the DP, right? So and actually, let's try. Let's do let's get the blocks first. So the first one is the n, right? So let's define like a integer, and which is the n here. Let's read the n in, because the n is the size, half size of the total array, right? That's why we also need like the numbers, the array to hold the numbers. So we have an integer of a dot max n, right? So is this like is integer okay here? Let's see. So the range of the numbers, they are like, yeah, they're just within like 2000. So yeah, so integer is more than enough to do this. So let's read the numbers in. So basically for I, int I starting from 1, we finish from 2 to n, right? And then I plus plus, and then let's read this thing here, in here, AI. Oh, and then the max here. So since the range is the range of n is only up to 2000, I'm gonna do this maximum to 4005. Yeah, that should be enough. Okay, so we have this, and now we have the inputs. Now for the blocks, I'm going to use a vector like of int to save the blocks. Basically, the value of the block is just the length, right? And to get the blocks, so I'm going to have like a start, right? Start equals to 1, right? And then for int I equals to 2, and I is smaller than 2 times n I plus plus. So you can use your own way to get these blocks. I'm just using mine. So mine is basically like if the current I is smaller than the starting point, okay? And then I just continue, right? Otherwise, else, okay, else we need to calculate the length of the previous blocks, which is the blocks dot push back the I minus start, right? And then we have start equals to I. So whenever we see a number which is greater than the starting point, right? And then we just calculate the block's length, and then we update the starting point to be the current one, because now we are at the new blocks. So in the end, don't forget to push the last block's length, which is the 2 times n minor start plus 1 start. right? So this is okay. So if we have 3, 2, 6, 5, and 4, like the 7, 4. I'm just giving an example here, right? So we start from here, right? So here is a start, and then we are at here. Then the first one is 2, and then we are at here. Then we got another blocks of 2. But when we are at the end, right, we haven't calculated the last one because the starting point is right here. This is a start, right? So start is what? Start is 1, 2, 3, 4, 5. So now the start equals to 5. And the total length of this one is 6. But we still have like the last block we need to calculate. That's why which is the 2 times n, right? Because n is 3 in this case. So we have 6 minus 5, right? Here, but the length is 2. That's why we do a plus 1. Okay, cool. So now we have the blocks, right? And the next thing is we just need to use the DP, the 01 knapsack logic to calculate the DP. I mean, we can do 2 ways. You know, the basic one is the just a two-dimensional DP, right? And the improved one is we can remove one of the dimensions. So, but let's try to do a two-dimension first, right? And then we can start. Okay, we can see from there. So we have two DPs here. I'm allocating like two-dimensional DPs, and the size is this one. The and the first one, right? So the base case 0, 0, right? So it's equal to true. So this DPI, right? So DPI means what? DPI J means is the first ice block. Can we get a length of J? If it is, then the value of this one is true, otherwise false. Okay, and later on, right? So once we have this one calculated some way, right? And in the end, then all we need to check is this one. If the DP of the let's say we have size here, right? So we have a size of the blocks, right? Blocks dot size, and then we have a size and then the n, right? So if this one is true, then we just output the yes, right? Else, else we output the no. Okay. Basically, we're saying that with all the blocks, can we get a length of n? So now the rest is just like the regular DP, right? So int I equals to 1 to the size, right? And then we have an inner loop, which is the capacity, right? And in this case, it's the target, which is n. Int j equals to 0, and then j is equals smaller than n, right? And then j plus plus. So two scenarios, right? So if the first scenario is we don't pick the current block, which is going to be the dpij equals to the dpi minus 1 j. Okay, and then if we decide to pick the current one, we have to check if the blocks, right, the blocks I minus 1, right, it's smaller than the j, then we can use the current block. dpij is equal to dp ij or the dpi minus 1, right, and then the j minus blocks I minus 1, right? So that's that. Yeah, I think that's it. And let's try to run a few test cases here. can just we can copy this one here. So we have what? We have yes, no, yes, yes, no, and no. So it seems correct, right? Yeah, so that's that, right? I mean, and of course we can just try to reduce this one to a 1D. Basically, since the DP I state only depending on the I minus one. That's why we can remove this one. Instead, we only use the capacity, which is n. That's why from here we can just do this one, remove this one, and then the same thing here, but we have to loop from the end, right? So we need to loop from the end, and then stop at the blocks I minus one. And then we do a j minus minus, right? We're decreasing j here. So here we just need to do a dpj equals to dpj or the dpj this one. Yeah, and in the end we just need to do this. We can remove the size. All we need to do is just dpn here. That's how we remove the one dimensional for the like blocks. So the reason I think I have already talked this part a few times. Since we're like need to use the previously I minus one's data, that's why we have to loop through from the end. Okay. Otherwise, we will have like otherwise, if we loop from the first, and then this one will become like a complete uh, knapsack problem. Yeah, I think that's it. So for the time complexity, right? I mean, um, so here we have an n, right? So we have a O of n here, and then for the knapsack problem, here's like a O of n square. So in total, the time complexity is O of n square to calculate this part. Um, yeah, I think that's it for this problem. And let me know what you guys think. And otherwise, I'll stop here. And thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.